Hello and welcome. Thank you for coming tonight. My name is Renata and I'm pleased to welcome you to our second workshop. For those of you who didn't attend the last workshop, I just want to give you a brief introduction to the purpose of this workshop and the fact that it is organized on behalf of the Grass Valley Energy Action Plan. Tonight's workshop, as you know, will be about building energy efficiency, which is a very thematic topic, especially here in California with the 2019 Building Energy Efficiency Code upgrades. And the workshop series is really intended to inform community members about how they can implement practical, cost-effective best practices in their homes and businesses to save energy, save money, and also improve air quality. So I will just say a few words about the Energy Action Plan. Last fall, in November, the City of Grass Valley approved a 3-year Energy Action Plan whose goals are to assess the energy use within the city limits, including electricity and propane, with ambitious goals for reduction of each of those types of fuels, as well as creating a long-term roadmap for energy efficiency, water efficiency, and renewable energy adoption, which will complement the existing policies of the general plan. So it's really exciting to see all of you here tonight. Thank you so much for coming, and I look forward to hearing what Ray has to say about existing buildings and how we can really enhance those to operate more efficiently and improve comfort and energy savings. So I will just say a few housekeeping items and then I'll introduce Ray. We have some snacks there. Feel free to take any refreshments or beverages after the workshop. Everything was donated, so if you could please just put in a few dollars there to help cover the costs of the event. That would be much appreciated. And also I want to let you know that we have a videographer here tonight who's donated his time, and we're trying to film this event to provide an educational resource to the public after tonight's workshop so that this information is accessible to anybody. And the goal is to put this on the City of Grass Valley's website in the near future. So if you don't feel comfortable being filmed, just let me know and I can accommodate you. And then lastly, I want to mention the registration. If you weren't able to sign in, I'm going to pass that around. And that's just to inform you of our upcoming workshops. There will be one more in June. And if you need to use the restrooms are right there on the left. So now I will introduce Ray. Ray Darby is a licensed mechanical engineer and an expert in building energy efficiency and solar energy. He worked at the California Energy Commission for 10 years, and he was previously known as the energy guy locally because he had authored a column on energy efficiency and renewable energy in the Union newspaper. He has worked in the field since 1979 in areas ranging from research and development to the design and construction of solar and energy efficient buildings. So without further ado, I will let Ray take over the stage.
Thanks. Great. So, has everyone heard about the new upcoming Title 24 for starting next year? All new buildings, all new residential buildings have to be net zero. Okay. So if you haven't heard about that, what that means is that buildings are going to be required by code before you can get a building permit to basically zero out their net usage over the course of a year. It's pretty significant. It's, I think, going to be another 5 years until it applies to commercial buildings. But this is what's coming down the pipe for residential buildings. So I'm not going to talk about net zero buildings because if you're building, or about new construction, if you're planning to build a home and you're not doing it before the end of this year, you're going to learn all about net zero there through that process. But I will talk a little bit about how it might apply to your existing building. 60% of the housing stock in Grass Valley, according to the Energy Action Plan research, those were pre-1978 buildings. 78 is when the energy code first came out. So full 60% of the buildings in this town are old buildings and have a huge potential for cost-effective savings. We're going to skim over a lot of topics, or through a lot of topics, I should say, simply because there's so many. I mean, the subject is huge. We could have an hour and a half workshop for months to really cover everything. So I'm just going to try to touch on the very most important items as I go through. If at some point you're not understanding something, please feel free to ask for clarification. What I'm going to, because I have so many things to go through, what I'm going to try to do is hold any additional questions on, any further questions on a subject till after I'm done, so I can get through everything. So Renata described my background, I think, pretty well. Don't need to go into that again, but I will say, if anyone's interested, that I've spent a lot of time with just about every technology you've ever heard of, and then some. For the most part, there's some where I don't go very deep, but there's a lot where I go very deep. So if anybody has any questions, I want you to feel free to, ask it when we're done. Also worked a lot with cities and counties. There's someone from the city here tonight. There's going to be someone from the city. Cities, counties, schools. I worked with them on energy efficiency, trained energy managers for commercial facilities. So kind of got a lot of different perspectives, so I want you to feel free to ask even questions that might seem outside the scope of what we're going to be talking about here. Okay, next slide, please. So just very briefly, Renata was talking about this plan. So the Energy Action Plan folks that put this together, Sierra Building Council, I think primarily was who was involved. They said, we have to establish where we're starting in order to see where we need to go. So they did what's called a baseline. Where are we right now with respect to our energy use compared to 2005? So they went back 12 years to see how things have changed in the last 12 years with residential, non-residential, municipal, public lighting. But really what we're going to be focusing on are the big guys here, and mostly residential, because that's you folks, which is a large part of the natural gas use. There's really not much propane in the city. It's all natural gas from PG&E. And then electricity was pretty huge as well. And basically over the last 12 years, we've dropped electricity use by about 2%, 8% natural gas. Commercial buildings dramatically increased the use of natural gas, but dropped electricity a little bit. The municipal folks, the city folks, who aren't here because they already know what they're doing, obviously, right? They dropped 31 and 20% electricity and gas. But overall, we've reduced electricity in the last 12 years by 3% and increased gas by 4%. Here's our goals for 2035, 15 years from now. We want to drop electricity 36, gas by 29, compared to the last 12 years over the next 15 years. So you kind of wrap your head around the goal. It's big. But it's totally achievable, and it makes a lot of sense for people. And next slide, please. And here's why. 3 primary reasons, benefits: economic, environmental, and energy. Economic-wise, we're talking about cost-effective savings for building owners. I'll define cost-effective in a minute here. And of course, if people are saving money and they have more disposable income, what's that going to do to the local economy and local businesses? People are going to benefit a lot from that. Environmental benefits: we'll have reduced outdoor air and water pollution. These cost-effective building measures can improve indoor air quality, health and safety for the people that inhabit them. And then in terms of energy, we'll have more resiliency, which I'll describe in a minute, and a more sustainable use of resources over the long term. And sustainable by definition is meeting our needs today without compromising the ability of future generations to meet their needs, which is the path that we're on currently. It's compromising. So with respect to economic benefits, It really depends on the individual circumstances, and in fact, it depends is probably the best answer to all kinds of questions like, does it make sense for me to do X or Y or Z? Oftentimes it depends. But what I'm going to try to cover here is the mother lode. Okay, we're in the gold country, so that's appropriate, right? The mother lode of those things that are typically cost effective. How do we measure cost effectiveness? Well, we're looking at the savings relative to the cost. There's different measures by which we can define cost effectiveness. There's payback, how many years does it take till I break even from my investment? There's a return on investment, which is an interesting concept. Think of it like this, return on investment. Somebody tell me what they think they can get in terms of a return, a no-risk return right now, locally here. Anybody want to give me a percent return on investment you could get from some sort of an investment, like say
I can make 0.25% in my savings account.
0.25%, okay. Do I hear 1%?
Actually,
2% of the CD.
2, yeah.
2%, awesome. And what's the inflation rate?
3.
Okay, so, okay, yeah. Probably enough economists in here to know what that means. So, return on investment, when it comes to renewable energy or energy efficiency, you look at it basically the same way. I'm going to spend X dollars on this energy efficiency measure. And over the next 10 years, I'm going to get a return through the savings on that investment. And what you'll find is that the return you get on an energy efficiency investment, the ones we're talking about here, for the most part, it depends to some extent. The return that you're going to get on a renewable energy system, again, depends, but typically it's going to blow that 2% out of the water and put you way above the rate of inflation. And so that's why when I go back to those goals, I think if we can just educate people, educate you educate others, we can get there because it's in people's best interests. Don't be putting your money in an interest earning account at 1/4 to 2%. It doesn't even keep up with inflation. And the other way to measure it is years to positive net cash flow, and I'll give you an example of that. Very important, how do you determine the savings? You've got to be careful, buyer beware out there. You got to consider the source. Salespeople oftentimes aren't giving you completely accurate information. It pays to really kind of compare bids and ask lots of questions and shop, which a lot of people don't do. I'm surprised all the time by that. Having an independent energy auditor can really help. Somebody that doesn't have a stake in the sale, somebody that can look at it from a completely independent point of view. So what do you choose? Payback, cash flow, return on investment, ROI? That's really up to you. Some people prefer one over the other. If people have lots of cash, it might be payback. I got $10,000 in my account that I want to invest and get a return. But I want it to pay back in 5 years, let's say. So people might just have an idea what their criteria is for making a decision. Cash flow I'll get to in a minute, as well as ROI. Okay. There we go. So here's an example of financing. This happens to be a solar project, but it could be anything. And it wasn't a particularly awesome solar example because it was a relatively low bill, not really great sunshine, 5 3/8% interest rate over 15 years. Assuming electricity escalates at about 5%, so that's an important thing to take into account when you're looking at how long is it going to take to pay back. The fact that the energy costs keep going up helps make things pay back sooner, right? So that's good. And I know it's a big table with a lot of numbers, but just if you kind of look at it from the standpoint of starting here, $1,000 down, just happens to be this example, sometimes it's 0. And then at the end of year 1, what happens? This particular case, they saved that much in electricity bills, but they had to pay that much in financing payments, so the red is negative. Okay. They saved this much, almost took care of the financing payments, but because it was an amortized loan, they got a deduction from the state, deduction from the federal government, and deductions, of course, talk to your tax advisor because there's limitations. Laws recently changed, but unless you've got a really, really big loan, you should be able to qualify for them. So all said and done at the end of the year 1, look at that big number. That's the 30% tax credit, which applies to solar, does not apply in most cases to energy efficiency, but there's exceptions. So they came out $7,738 ahead at the end of the first year. Altogether, well, you got to take the $1,000 that they paid up front, so they're only this far ahead. They're only $6,738 ahead. By the end of year 2, the change in, there's no tax credit left anymore. Although if they couldn't use all that, they could roll it over the subsequent years. They're $229 ahead. Or if they stored it all under their pillow, it would add up to this much. Does that make sense? Everybody understand that? So then you march down year to year, and every year the savings increase because the cost of electricity keeps going up. The payments remain the same, but the savings keep going up at 5%. The tax benefits keep going down because you're paying more and more principal. As you get towards the end of the loan, it starts out mostly interest. So at any rate, this is a financing example. So one might ask, what's the payback in a situation like this? How many years did it take for this investment to pay off with financing?
15 years.
Less than 1.
Immediate, yeah. So when people say, well, gosh, I don't know about if I can afford to make changes to my home. I don't know if I can afford to upgrade the attic insulation or do some of the other things we're going to be talking about. You can get loans for that stuff. And in fact, the Energy Action Plan, and it's going to be, how are you going to make that available to everybody? Email them?
Yes, I will provide links to all of the current energy efficiency programs and rebates from the Energy Action Plan.
The Energy Action Plan, if anybody's interested, it's a really, really great read. I mean, I really enjoyed it. But there's appendices, that's me, right? The appendices at the end, they talk about different programs that are available to people, financing, but there's financing available from your local banks. As general contractors as well as solar contractors, we have financing that we make available to people to do the whole thing. Renewable, energy efficiency upgrades all can be rolled into one. There's the Empower Placer program that loans money out for a wide range of different measures. And there's lots of really wonderful purveyors of solar and energy efficiency in Nevada County. Remember the shop thing earlier? You got some good shopping to do locally here. So this is an opportunity for people that don't have $5, $10, $20, $30,000 of cash laying around, which I don't know. People want to raise their hand with me, but it can work. It can work for you. So as far as getting into the environmental part, I was really involved with the Union of Concerned Scientists for a long time. And one of the things that they did was this study on what was the environmental impact of a typical American household. Really, really interesting. And I got to be part of the review team for this little book. And you can actually look this up on Amazon. They got a whole bunch of it now, I just discovered. Actually available for reading. You don't even have to buy it, but it's $12 and well worth the price. Keyword, effective. As a environmentalist that really cares about what really makes a difference, this book would blow your mind. There's a lot of misconceptions in the environment, in people with an environmental ethic about what really makes the most difference. And it'll blow your mind. Recycling, great, but that's chump change. That's the small stuff. There's much bigger stuff. And as part of reviewing this book, it's full of tables. Tables. And I said, you know, guys, not a lot of people besides me are going to be interested in trying to sift through all these tables. What if we did a chart? And they're like, nah, we don't want to do a chart. So I did a chart. Next slide. It's not in the book, but it's available here. And what's really interesting about what we found, or what I didn't find, I was just reviewing the book. A bunch of scientists with the union figured this all out. For, again, a typical American household doesn't necessarily represent Nevada County, okay? But environmental impact, there's no such thing as unenvironmental impact. There are categories. You got greenhouse gases, air pollution, common, toxic, same thing with water pollution, common and toxic, habitat alteration in terms of water and land use, different categories. This key kind of takes you from the bottom of the chart up by color. The first part is transportation. The next is food. I'm not going to talk about either one of those, although I would really love to, but maybe another workshop. And then household operations, and this is about 99% electricity and gas, which is what we're going to be talking about today. Notice something here interesting. Greenhouse gases. Your household electricity use, at least typical American family, is actually contributing a little more to greenhouse gases than transportation. But then if you want to talk toxic air pollution, wow, what you driving, right? Makes a big difference. Water pollution, what are you eating? And how much of it? You know, is it local, is it organic? So just in one graph, what really struck me after I put this together was that just these three categories, transportation, food, and household operations, that's why I drew this little line here. If you come up to the top three, there's worldwide wrestling going on up there. It's about 80% across the board. Look at that. You know, these three, 80%. So if you focus on these three in your household, if you care about the environment, that's where you're going to make the most difference. The other thing that I've been really interested in the issue of climate change for years, and this is another thing the union, those concerned scientists, put together, and we all got a pre-release copy, don't distribute till we've had a chance to talk about it. This is from 1999. I just broke this out the other day to show Anata, and I was leafing through it. It would chill you to the bone. The section on wildfires.
They're right on the money, aren't they?
20 years ago, 1999. Yeah. So it's not like this is something new, you know. We've known about this for a while. Next slide. Okay, on resilience, this is the energy part. And we spent a lot of time talking about this, but resilience is important to us as a community. Why? Well, maybe just go down the hazard column. How much do we like disruptions in our power? When the power goes out. Nobody's big fans of having PG&E go down all of a sudden because there's a little wind kicking up. Loss of power at critical loads. So it's the summertime, there's not enough power to go around because everybody's turning their air conditioners on. There's things that we can do about that as a community. Inability to shelter in place safely. There's, you know, issues with buildings. I mean, there are senior citizens that don't have much money that have a hard time keeping warm in the winter or cool in the summer. Anybody experienced extreme discomfort in the summer months in your home? You know what I'm talking There's climate change. We were just looking at that. I won't go into that too much because that's outside the scope here, but it's a far more serious issue than I believe 95% of the population can comprehend. I've been looking at it since around 1980. But it was in the 90s that it really started hitting me. Working at the California Energy Commission, every month the journal Science would come in. And so the first time I was looking through it, I thought, wow, this sounds pretty serious. And then I wonder what the next issue has, the latest research. Oh my gosh, really? Seriously? Peer-reviewed stuff? You know, it's pretty scary stuff. But at any rate, these are all the resilience categories, if you will, and some of the indicators, hazards, and solutions. And this whole slideshow will be available for people later, so
Great.
I won't spend a lot more time on that for now. So these are our 3 topics for today, and I'm going to try and roll through them quickly here. Conservation, efficiency, renewables, and the big picture, which is kind of putting them all together. And so I'll hit those one at a time. Conservation, free stuff, right? It's actually free. Turn off unused lights. Yeah, everybody knows that. Okay. Adjust the indoor temperature when you're away. It turns out that you can save about 20% of your heating and cooling energy if you just turn the temperature down when you're away. How many people here are away during the day, typically in the week? Okay, huge amount of energy savings potential there, just by turning things down when you're gone. Maybe 10, 15 degrees. You can do that before you leave, or you can have a setback thermostat that does that automatically for you. Nowadays, there's these fancy little, things on your phone you can use to bring things up to temperature and down, as the case may be. And here's a big one: adjust your refrigerator or freezer temperatures. When I do energy efficiency assessments, it never ceases to amaze me how many refrigerators and freezers are out of whack. Refrigerators should be run around 38 to 40, freezers around 0 to 10. I've seen lots of freezers at -10. And being that much colder dramatically increases the energy use of that unit. Clothes drying, super simple. Moisture sensor control, we've got to get ours fixed, but when it works, it's great. That can save about 10-15% right there, just by not using the timer feature on your clothes dryer, having it shut off when they're at the drying level that you want. The lint filter cleans up pretty easily. The more that gets blocked up, the more that gas, flame, or electric element is trying to heat, the longer it's operating to try to get the clothes dry, because it can't get the moisture-laden air that it's taking out of the clothes out fast enough. The ducting, anybody here not ever look at the ducting coming out of the back of their dryer? It's a little hard to do. You've got to kind of climb up and look over, but it's a flexible metal typically, or plastic duct, and it's got lots of little ridges in it. So to the extent that there's a whole bunch of fat, it's this long, but you're using, you got it compressed down to this much. All those little ridges slow the air on its way out. And that, again, the more you slow the air down with lint or with the ducting, the longer it takes to cool or to dry the clothes. Do it when it's cool outside. So you got the windows open in the summer, for example. You're helping to not have to use your AC, right? Or you can use an indoor air dry rack, or even Mr. Sun to dry your clothes. Clothes washer, use cold water. So people that don't use cold water, a hot water wash is the hot water alone is about 90% of the total energy for that cycle. So cold water makes a big difference. Dishwasher, no heated dry, that'll save around 10%. Just let them air dry, turn the heated dry off. In the wintertime, open or close your interior shades,
Why not the
depending. One of the things, being a passive solar guy, passive solar means you're using the sunlight coming through your windows in the south facade typically of your home to help heat your home in the winter. It never ceases to amaze me how many south-facing windows I see with the drapes closed. Let the sunshine in. That's free heat that people are missing. That's free stuff. Close off unused rooms. A lot of people do that. Is that a good idea? In a lot of cases, it's not. And then natural night ventilation and cooling. All you got to do is run around, open windows. Lighting. Don't really want to say a whole lot about that because I think everybody understands that. Use your brains and fingers, turn off lights when you're not using them. You can do it automatically with motion or photo sensors. Recessed can lights, those are these guys here. UGG, I'll explain that in a minute. There's all kinds of alternative light bulbs, fixtures, and switching. One of the things that drives me crazy is light switches that turn on like 12, 15, 20 lamps at a time. Really big in new construction. Not necessary. And doesn't give you a lot of choice for, turning on the lights that you need for the task or that you happen to be in the space performing. In the Energy Action Plan, a really great case study, Foothill Mercantiles, everybody know where that is, over on East Main. They're saving $2,800 a year from a lighting upgrade. They put in LED lights. It only cost them this much. So, basically they're getting payback in about 1 year. They got a PG&E incentive to help, but even if they didn't get that incentive, that's a 2-year payback. Pretty amazing, right? Next slide, please. So, energy efficiency in the building envelope. This is a really, really big deal. Air sealing, way bigger than most people realize. Does anybody know what this is? This is your home, believe it or not. This is your home. And when most people think of air leaks, what do you think of? Doors and windows. That's the small stuff. The big stuff would blow your mind. I'll get to that in a sec. As far as the rest of the building envelope, and the envelope is just what envelopes your conditioned space, your heated or cooled space. That's where the term envelope comes from. And so around the envelope, in addition to leaks like a colander, you have insulation. There's some opportunities like cool roofs. And there's window change-outs, a real popular one that I always hear, I just changed my windows out because I heard that was the best thing to do. Maybe not. Talk about that. And then solar heat gain is another energy efficiency measure that can help you heat in the wintertime. If you open your drapes in the winter, open them up, let the sunshine in. And then in the summertime, closing your drapes makes a big difference. No, we'll talk about that.
Is that the order for the attic? Is it for insulation, attic, floor, and walls?
I'll get to that in just a sec. It's a good question. So air leaks, common air leaks. Believe it or not, and this isn't my favorite graph, but I'm too lazy to make up my own. Let's pretend this is a crawl space. And you typically have in your crawl space heating ducts. And then you have registers. And I don't know if you've ever tried it or not, but if you have a forced air heating system, you can take one of those floor registers and just lift the register right up and look inside. And we'll see what that looks like in a minute in most homes. That's a huge source of air leakage. And where is that air coming from? It's not coming through the door. See, do we even have a door in this? Yeah, there we go. So this is what most people are thinking of, right? The air is coming in at the threshold, sealed air. That's nice, fresh air. Awesome. the air that's coming in from the crawl space, do you want to breathe that crawl space air? Does anybody like to go hang out in the crawl space and go, no, you don't. But that's where more air is coming into your home typically than through that nice little fresh air vent underneath your door. And most windows don't leak much either, so that's not an issue. And of course, what comes in, whether it's through the crawl space or the under door, must go out, right? And so it finds its way out through little openings in the ceiling, which are also maybe ducting, might be an attic, access door, any light or other penetration in the envelope. So you might have a light in the ceiling that's got an electrical box behind it. And around that electrical box, there's an opening. And there's little openings in the electrical box. And that's where the air goes out. So it's like a chimney. And the warmer it is inside and the colder it is outside, the more powerful that chimney is. And the air just rushes in and rushes out. The bigger the temperature difference. And the bigger the temperature difference, the more you're paying for that outside air that's coming in. Okay. So yeah, I didn't know that we were going to have these lights because I hadn't been here before, but that's a recessed light. And this is what it looks like with the pretty little cover off. This is called the rough opening, and this is what goes right through into the attic. So the little cover that's on there typically does not prevent leakage around it and into here. And then within the can, so it's like a coffee can upside down, right? There's all these little holes in it where springs attach and things like that. And the air just rushes through. When I do infrared video, these things just glow because there's so much loss going through them. And so what we can do in cases like this is these can completely be removed, and then something like this can be put in, which is awesome because it's super low profile. It goes right into that little space, and then insulation fills over the top of it. With most of these old recessed light fixtures, you can't put insulation around them because they get too hot. They'll actually catch fire. So most of the attics I see in Grass Valley and in Nevada County in general, the insulation's held back. And I can, in the attic, look right through and turn the attic light off or my headlamp off, and I can see all kinds of light down there. I can even see people walking around through these little holes in this thing. That's how big they are. So replacing these with something like that is a really good move. Okay, here's what it might look like when you take that register out of your floor. This is really common. Not quite this bad. I picked this one because this is especially egregious. Because you can see this can, sheet metal can, it's called a boot, and the duct connects to the boot. This can typically has a space between the can and the floor where it was cut out. And you can take your register off, put your hand down there. It's like there's a breeze coming through between this can and the floor cut out. And that's crawl space air. Don't worry about the air coming in under their front door threshold. That's fresh air. This is foul air. And this is a pretty easy thing to fix. Next slide, please. So we're going to have another presenter coming up next June 3rd. That's going to talk about HVAC, but real briefly, this is how you want an HVAC system to work. The air goes in the return, sucks it in, goes through a duct, goes into your heating and cooling unit, is then supplied, so we call it supply air, to registers in your home. And this is what we want, right? All the air comes in, gets heated up or cooled down, goes and flows back in again. Next slide, please. This is unfortunately the average house in California. As a building performance contractor, we like to get a little crass. And you probably heard the term or somebody say at some point, wow, that really sucks. Or man, that really blows. Well, that's kind of an inside joke in building performance because ducts suck and they blow. And here's how. There's leaks. when the fan is on average 20%, so there's situations much worse and not as bad, 20% of the air that's being moved by this fan gets sucked in via leakage. So where are these ducts where it's getting sucked in? Where are these ducts where it's getting blown out? Depends. This might be sucking air in from your attic. So you got attic air that you're paying money to suck in and distribute through your home. How awesome is that? Or maybe it's sucking in through the crawl space, depends on where these are, and vice versa. Now, here we get to the point where, you know, I'm closing doors, or equivalent, closing a register in the room to save energy. Seems logical, right? Well, not if you've got duct leaks. Because then what happens is you're really exacerbating the problem. Or let's say your duct system is completely tight, and this is your situation. Then what happens is your furnace fan is trying to pump air into this room, but you got the register closed or the door closed. What's going to happen? Well, it's not going to blow this up. You know, it's not going to scatter building parts all over the neighborhood. What it's going to do is that air is going to find little leaks in the building envelope to get out through. And what goes out must come in, just like what goes up must come down. So you're paying money to push air that you've heated or cooled into the great outdoors and pull in outside cold air in the winter, hot air in the summer by closing a door. Not always a good idea. How much insulation do you need? This is our area here. So,
Can I interrupt you a minute?
yes.
I actually am in a position where I might be able to give a little bit more insight, if you mind. On the ductwork, when we close off rooms or we close off vents, our HVAC systems are designed, they're octopuses, right? They have all these ducts going through all your house. If you close off too many, it puts back pressure on your system. It's designed, that octopus is designed to push air for so many square footage throughout your size of your house. It's gauged to fit your house size. If you close off things, you put back pressure, and what sometimes happens is you can blow one of your ducts off its track, and so it's no longer connected. So you're actually heating underneath the house, you're heating a duct, you're cooling, whatever. It's no longer connected. You put so much pressure in your ductwork, it's dismounted. They say about 80 to 90% of all homes have either leaky ducts or dismounted ducts, disconnected ducts. Just not fully disconnected, sometimes partially. It's just pushed through. The air pressure is so much, so you don't want to, you also ruin the life of your HVAC system if you put too much back pressure on the fan motor. It's just not designed that way. If the fan is designed to push so much air, so many square foot CFMs per minute. And so it really is a problem for you if you start dislodging your ductwork. It's no longer serving your needs.
So I had someone recently who was not getting enough cooling in their upstairs rooms, and they had this vertical chase, what we call a chase, had the ducting going all the way up, serving the upstairs rooms, and they were not getting enough cooling. Solar customer, she called me up and she said, I got 5 heating bids, are all around, $13,000 to $16,000. Can you come and help me look at them? Went over there and found out she had a partially disconnected duct right here. And so what was that doing? Well, that's why she wasn't getting any cooling to her baby's room or her kids' rooms upstairs. They were sweltering up there. So she was very game. Had nice, pull down steps up into the attic. So we went up there and holy mackerel, look at that. There's feeling cool air up there. So I said, I think you've got a disconnected duct. So she had her handyman come and fix that and then sent me the results, and her bill just plummeted. Her cooling bill plummeted. And all of a sudden, everybody was nice and cold, chilly, and happy upstairs. This partially disconnected duct.
It's very, very common.
Very
We
common,
would like
yeah.
to know.
Thank you for There's so much, we could go so deep on this. I think you want to go to the next. So how much insulation do you have and versus what you need? In this area, this is kind of the minimum. This is what I typically see, maybe 3 to 5 inches I see in an attic. This is one of the cheapest things that you can do to your house, and it makes a huge difference. But before you do this, you want to go air seal all those little holes. And if you want more information on all of that, all you have to do is Google air seal, insulate, Energy Star. And do it yourself instructions. I mean, the amount of information that Energy Star has before current administration shuts it down. Yeah, I'm not going to go there. It's amazing. But yeah, you want a foot plus, maybe a foot, foot and a half of insulation in there. And it's really cheap. You just blow it in. Next slide. This is the floor. This is terrible. This is a typical floor. If you've ever crawled around in your crawl space, this is probably what you see. The insulation's hanging down. They use these steel rods called lightning rods, kind of push them up like this, hold the insulation in place. It compresses it here, takes a little air, have the air spaces out, and that reduces the effectiveness. It tends to not completely go to the end of its run, and there's a space there, and you can just see the air can go up like this and between the insulation and the floor, making it virtually useless. This is what I typically see. But you can do it differently. And there's lots of different ways to do it. In my particular case, I put it in there, I kept it all nice and fluffy, I butted it up against everything so there wasn't any little spaces where I could see the floor. And then I ran a vapor permeable membrane like Tyvek, which is an infiltration barrier, not a vapor barrier, but it's permeable to vapor, underneath, which holds it all in place and seals in all the juices. So, great way to go. Cool roofs. This really applies to a white roof, and I'll show a couple of examples. We actually did this back in 2004. I shared a building with the Contractors Association over off New Mohawk, flat roof, and we put a reflective coating on it. And the day before, you literally could not walk on the roof. It was way too hot to touch. I think it was like around 160 degrees on a 92-degree summer day. The next day with the cool roof, the surface of the roof is a couple degrees above the ambient temperature, which is also about 92. Reflects about 80%. Next slide. So we did a coating on a roof very similar to this. There's metal products, there's membranes, which is like a material made out of a special type of plastic that rolls out. It's available in tile. Shingles, a lot of people don't like white shingles, but there are cool roof shingles that are colored. They just don't reflect nearly as much as a white does, but there's products available to the extent that you don't have a lot of insulation. So huge benefit in a case like that, because in a building like this, or maybe you have a building with a roof like this, but you don't have an attic. If you don't have an attic, it's very expensive to add insulation. But if you put a cool roof on, now all of a sudden in the summertime, it doesn't feel like a radiant heater at 105 degrees baking your face. It's going to be nice and cool. Windows, generally, despite what the salesman may say, much less cost effective than the other options. You can just make, when you do these, you can oftentimes need to make changes to your trim around the window or the sills. But again, shop around if you want to do a window replacement. It's not really typically going to pay off in terms of return on investment. The reason I include it here is because of comfort. It will increase comfort. And there's a little bit of energy savings there, because if you got drafty windows or maybe you've got no insulation in the floor, like my daughter's house, In the wintertime, she has to keep the temperature around 74 to be comfortable. You got to keep it much cooler in the summertime. The air temperature, if you don't have insulation in the ceiling, all of those things affect comfort. But in the case of windows, that's the primary benefit. You may also want to replace them because they're fogged from broken seals, or maybe they don't open and close right anymore. But on older windows, you can do repair of the weather stripping or put in solar storm windows. Those are great for historical buildings where you don't want to, change the aesthetics of the windows. And then to prevent heat gain in the summertime, you can use a solar awning or a solar screen. Pass around a screen example. They will cut out, an awning or a screen can cut out 100% of the direct sun hitting the window. So in the summertime, walk around your house, are there any windows getting direct sun? That interior drape is doing almost nothing. I have a little temperature gun. I go into houses in the summertime. Somebody's got the drapes closed. They can't see out. They're getting very little light in, and they think they're reducing the solar heat gain on that west facade. I'll point the little sensor at the surface. It might be 105, 110 degrees. So it's like a little heater, basically. You put that solar screen on the outside, it cuts out 90%, 80%, depending on what it is, as opposed to maybe 20 to 50%. Next slide.
Just curious where you can find those, right?
Yeah, probably. Let's see if we can get to that.
At the end.
I'm trying to get through all of this.
Okay.
And we're getting close. So efficiency, HVAC is coming next month on the 3rd, right? You definitely want to be here for that. I'm just going to touch a little bit on ventilation. And that's because it kind of completes the building envelope piece. Night ventilation cooling, everybody knows you can open the windows up at night and get cool air in. Sometimes it's fan force, like the whole house ventilation fan. You can use an evaporative cooler, kind of achieve the same thing, or just naturally by opening windows. And of course, outside air is important for human health. So there's actually requirements. I was going to talk about commercial building requirements, but there's nobody here that applies to, so we'll skip that. This is what you typically see a whole house fan look like. And these things leak like sieves. You want to talk about, colanders. This is one of the biggest colanders in a home, whenever those exist. We've built insulation boxes with hinged lids and weather stripping around it in some cases. But a much better solution is something like this, where it has insulated louvers instead of louvers. I can look through and, people can tell me I can tell how many fingers they're holding up. And you can just feel the air rushing through there from the attic side. Let's see, go back just one sec, please. So what this does is has insulated louvers here, and it's got a fan up here. And then this duct is like a muffler. So instead of sounding like a 747 taking off right outside your bedroom window, you got a nice quiet way of getting the air out. One of the biggest problems, though, I see with whole house fans is there's not enough places for the air to get out of the attic. That's a huge deal. Even professionals, when they install these, don't often think about that enough. And so then what happens? Well, this gets really pressurized, and then all those other leaks you haven't sealed yet, that hot attic air, some of it comes in back into the house. Night ventilation, pretty straightforward to keep the house closed up during the day. The heat that does come in kind of gets absorbed by the interior fabric of the building. At night, you scrub all that heat out by bringing the cool air in and letting it go out. If you're lucky enough to have a 2-story home, that makes a huge difference. You might not need a whole house fan if you've got a 2-story home and you got that chimney working for you. You get lots of lower and upper windows open, and you get a natural chimney effect. With a 1-story home, not so much, but a whole house fan can really help in either case. Now here's a fan that I hate. This is a much better one, it's solar, but they're both not a good idea typically. And I could go into the reason for that, but I think I'm short on time, so if anybody wants to ask later. This is a really great fan. A ceiling fan makes you feel about maybe 5 degrees cooler, 4 to 5 degrees cooler than you would if you didn't have that air movement. But only if you're feeling air movement. If you're not in the room, turn it off. Because these little motors here are not 100% efficient. So maybe 15% of the energy that you're spending to turn that blade is coming into your living space in the form of electric heat. And you don't want to run electric heaters in the summertime. So always turn them off when you leave. So solar is great. You do a whole bunch of things to save energy, and then maybe you've got enough bill left over to cover the rest of it with solar and get closer to net zero. If your bill is averaging maybe 100 a month or more, again, it depends. It's going to be cost effective. And the bigger your bill, the more cost effective it is. East and west roof directions are fine. I won't go into a lot of detail there, but an east or west, depending on the slope of the roof, is going to be somewhere around 84 to 88% of the energy that you get facing due south, with a south facing roof. Not too shady is good. Roof mounted systems have the benefit of being a little cheaper. Ground mounted systems cost a little bit more, but you don't have to remove them when you go to re-roof, and they're easy to clean off when you get lots of pollen like you do this time of year. But there's advantages and disadvantages to both. Payback is typically 4 to 7 years. A return on investment of around 15 to 22%. That's a little bit better than the 1/4 to 2% that we're getting with other investments out there. Long-term warranties of 25 years are common now. With solar, you really have to be aware of being oversold. I won't overemphasize that. Can't overemphasize that enough. But with solar, you can cover space heating, water heating, and as well as transportation. And I could say a lot more about that, but short on time and lots and lots of things to cover. So is it cost effective to create a net zero home? In new construction, absolutely yes. That's why Title 24 requires it, because Title 24 has to be proven cost effective, or you can't have that code go into effect. I worked on the code in '92, and that was my job, to work with the building industry elbow to elbow with computer simulations and economic evaluations to verify to the building industry satisfaction that it was cost effective. So come 2020, everybody building a new home is going to be bitching and moaning about, oh, I got to do solar and all this energy efficiency stuff. Well, guess what? It's giving you a return on investment. So tough cookies. Let's see, go back one sec. I want to make sure I didn't forget anything. So yeah, it is a matter of utilizing all your most cost-effective energy conservation, free stuff, and energy efficiency options, which have high returns. Some just like the solar example I was given there. And then if you're using gas, how do you get to net zero? You can't make your own gas. Well, some people do, but that's not an appropriate joke. Gas heating, space heating, and gas water heating can be done with electricity. And that can be covered with solar. So it is possible to get to net zero and eliminate your carbon footprint. My place is an example, not the best example because it's still a work in progress, but it was a '73 vintage home, had electric wall heaters, an electric water heater, super leaky single pane windows. There was no floor insulation. There was about that much in the attic. It was built as a little summer cabin, way too small for my family. We added solar water heating in '83. That took care of about 90% of our hot water. We did an addition remodel in '87 to take it from 800 to 1,400 square feet for our family of 5 at the time. We added passive solar design. It was an addition remodel. So I ripped out all those single pane windows, and the new ones I put in, 50% of them all face south. So in the wintertime, because we have about 45% possible sun in western Nevada County, 45% of the time when Mr. Sun's shining, I don't need to use any heat. All my neighbors that don't have passive solar, their wood stoves are going. So huge benefit by virtue of doing an addition and remodel. We put in stamped concrete and other thermal mass to help absorb and hold that heat that was coming in during the sunny day. Hot water, radiant floor, hot water circulating through the floor for space heating. High performance windows. Today's modern windows don't let very much sun in. You actually have to get special windows that still let the sun in, like the old double pane used to do. It's actually not easy to find them, but if you're remodeling or doing an addition, these are some considerations. And then on the east and west windows, you just use the standard glazing or glass that you get these days. It cuts the solar heat gain down quite a bit because you don't want it coming in from the east and west in the summertime. But you want as much south as you can and open those drapes up if you have south windows. We've got advanced evaporative cooling, which we also use as ventilation. But to go net zero, now I'm considering, I recently learned about a heat pump water heater that can not only heat my hot water, but provide the hot water for my floor heating. So my place is an example, and we did this on bare bones budget and low interest loans, and really paid off. And it's 7:09. Nobody's gone to sleep yet. If anybody have any questions?
Yes, we have 10 minutes now for a Q&A session, so please direct any questions you have to Ray.
Yes.
So I have a son who lives in a really tight house in a cold area, and he tried to tell me that if you just set your temperature where you want it and don't go up and down, because if you go down, you lose the mass temperature in your walls and you just have to heat them up again. I find in my little 50s house here that I don't think that's true. And I don't know any way to judge that.
Well, if you're gone for any significant amount of time,
Well,
it's
I'm
always
talking
gonna
about
save.
going to work in the morning,
Yeah.
you know.
turn it
set
down a little
58 or
bit.
something like
The
that.
heat that's in there is gonna percolate out. So you're utilizing it to help maintain the temperature as it's kind of cruising on its way down. And then when it comes back on again, you're not only gonna heat the air, which happens like that, but you're also gonna reheat that mass up a little bit. So there's really no loss involved in losing a little bit out of the interior fabric of your building into the house, but you do save on keeping that temperature constant as opposed to letting it float down and then bringing it back up again. So there's net benefit. Yeah.
Yeah, I think we also saw a recent example of an HVAC contractor put in a new heat pump, and we found that it cost him more in terms of kilowatt hours and the associated cost with it to heat the home back up after 3 o'clock in the afternoon after they got home, rather than just letting his nice tight house run with his efficient heat pump. Keeping it constant temperature all day long was more cost effective for him.
Yeah. Well, that brings up a really important point, and that is when you're using electricity, and it applies to mostly just solar connected folks right now, but come next year, what's the date for
November 2020.
November 2020 is when everybody's going to be on a time of use rate schedule. So when you use power, it's probably going to be like, what, 4 to 9 maybe, or
3 to 8 or 4 to 9, depending on.
3 to 8 or 4 to 9 is when power is going to cost you a lot of money. So in a case like that, remember that it depends, there's exceptions to every rule. You set it back during the day, you get home and crank that air conditioning up, it's going to be spinning your meter at the most expensive time of day. Not a good idea. So what you can do is use that cheaper power before that to get your house even a little cooler, so that come you come home and the house is still cool, and then, you know, depends on how hot it gets outside, you can play around with it. But then come 8 or 9 o'clock, then you can turn your unit on, and your house will have floated up to that point where you need to turn it on. So there's ways that you can kind of game, you know, the control of your home to minimize the cost and to use power off-peak, because we could get into another situation like we had back in 2000 when I developed the Cool Roof Rebate Program as part of a statewide effort to drop the peak load. You remember the rolling blackouts and brownouts? Yeah. There were 7 of us that had millions of dollars tossed in our lap, and the governor said, 1 year, turn it around. And it was very challenging, but that was the result of not just everybody running their air conditioners at the same time, but these server farms down in San Jose were growing like bean sprouts. And that was a big factor in contributing to the overload of the grid. And now what do we have? Everybody's wanting to grow pot indoors. That's the next server farm scenario. You know, anybody growing pot, grow it outside, please. Yeah.
I wanted to know more about your thoughts of the attic fans and why you were not good to see them all over the place.
Yeah. Well, typically, kind of like the whole house fan, what it's trying to do is it's trying to suck air out of the attic. So here's the attic fan. It's doing this, and really bad picture. I apologize, but here's your attic and here's your house, and so it's trying to suck air out of the attic and bringing it in through maybe a gable end vent on the other side or soffit vents or something like that. But what ends up happening is it's creating a negative pressure in here. It's trying to implode the attic. And then what that does is all these little leaks here, what goes in, it's getting sucked into here by the attic fan, is coming in from the outside. So you're basically using this, solar powered or not, to suck in outside air into your home. That's one thing. Okay. The other thing is, this is really ineffective at reducing the attic temperature, but more importantly, the flow of heat from the attic into your home. The predominant, by far and away, biggest way that the heat gets from your attic into your house is not from the temperature of the air, but from radiation, because your roof sheathing gets really hot. That radiates down to the attic floor. A researcher that I worked with told me an interesting story, if you can relate to this. He said, okay, I did these measurements. Here's the attic insulation. And I put a temperature sensor there. I put one up here on the roof. Sorry, I'm messing up your drawing. And I put a sensor here, going down into the insulation. I put one in the house. So he's looking at the attic air temperature. He was looking at the temperature at the top of the insulation and going down in the insulation. 2 in the afternoon, guess what? It was hotter here, a couple inches down in the insulation than it was in the attic air. So you can ventilate the heck out of the attic, but that radiation is going to kick its butt.
So would a ridge vent be a better idea than one of those fans, or?
Well, still it's ventilation. Really what you want is if you build this insulation up to what we were looking at there, you know, maybe 18 inches or so, then this can get as hot as it wants. And the fan isn't going to really make that much difference. But of course, before you added that insulation, you sealed all the air leaks too. Okay. That's the way to deal with the heat gain in the attic. Another way is with a radiant barrier. It's put on the inside of the roof sheathing that prevents that radiation from coming down, or a cool roof on the outside to stop it before it even gets in.
Hey Ray, real quick, I learned from a contractor that works out in Georgia, one of the ways you can kind of check to see how much, if you're getting any leakage like that, is go find the top of a door jamb or someplace that doesn't get dusted all the time. Wipe the dust off and sprinkle it in a glass of water. The dirt dust will sink, but the insulation that's coming through will float on the top of the glass. And you can kind of see how much you're actually losing through that. And that was one of his big things, is sealing that up. for
Interesting, so he's using dust that's come through the leaks in the attic?
Yep.
And I've never heard of that. That's
He
interesting.
taught me that, so the insulation will float,
Uh-huh,
and the rest of the dirt itself will sink. So
interesting.
you can kind of see, I mean, it's a way to see it.
Incense can also be used whenever you have a big temperature difference between inside and outside, a little bit of incense can be a good indicator.
I have a question, Ray. What kinds of insulative materials do you recommend?
Well, really depends on how it's put in, but typically in most situations, just a loose fill is going to make the most sense if you don't have any to begin with. If we're talking in the attic, if you're talking about crawl space, fiberglass is typically what's used, or there's a lot of alternative mineral wool and shredded Levi jeans and all kinds of different materials can be used to insulate. But in an attic, because more often than not, what you're starting out was that far left example where, here's the ceiling and here's the framing. And this is so typical. I mean, I'd be willing to bet you half the people in this room have this situation going on, where you've got just a little bit like this, maybe 3 or 4 inches of insulation. And this is a 6 inch, actually 5.5 inch nominal framing member. Maybe they're 4 inch, depends, but not very much insulation. And the heat has a tough time moving through insulation, but it really screams through the wood because the wood doesn't insulate as well as insulation. So when you blow insulation in, you cover up, I like to call these BTU, British Thermal Unit, superhighways. You cover up with that extra insulation the framing, and you add insulation, and this insulation is oftentimes not installed properly, so maybe it doesn't go all the way to there, maybe it stops right here. So the blown in insulation will fill up all those little nooks and crannies and provide a nice even dense layer of insulation that's continuous all the way across. Always seal the air leaks first. Installers will put in, they'll actually put little measuring sticks that stay there throughout the attic so they can show you what depth it is. There's a lot of science to loose fill insulation application, make sure it's the right density, it doesn't settle too much. But the insulation guys know how to do all that.
We have time for one more question.
Okay.
Can I ask you a couple about your place?
Sure.
So your hydronic hot water radiant floor heating, was that electric or was it on demand?
Right now it's gas.
It's gas? And then the high performance windows, are they like E-windows or Argon or something like that?
It's a special type of, so the ones on the south are a special type of low E that's high solar heat gain. It's called a hard coat low E. Soft coat is what's typical. It has a higher solar heat gain coefficient. So the soft coat low E is what you typically get. It's really hard to find the other stuff. And that's really cuts down on the solar heat gain, which is great for east, west, north windows. But for south windows, if you're retrofitting and you've got solar potential on your south windows, to put in something that doesn't reduce the solar heat gain is actually very beneficial.
So it's called HART or HART?
Hard to coat.
And then what advanced evac cooling ventilation system do you use?
Well, in our case, it's actually a very cheap little window unit. We put them in central systems, but the advanced evaporative cooling isn't just your regular little father's aspen pad type unit, with the thin little pads you can see through really easily. It's a treated paper honeycomb-like product that's thick. I mean, ours is about maybe this thick, but we've done whole house evaporative cooling systems with automatic relief air where the pads are about like this.
Wow.
and you can't really see through. And the water, the reason they're advanced and more efficient is they wet the air going through them a lot more thoroughly because there's so much surface area of the air going through exposed to that water.
Well, I have about a 1,400 square foot house. I have one evaporative cooler, an Australian one called Debonair, $1 a day, 78 degrees.
It's, yeah, the Bonaire.
Bonaire, that
Yeah.
series, the thing's, and I got the smallest one, amazing, $1 a day.
That's got the advanced media.
Oh, it does,
Yeah.
okay.
Okay.
Yeah.
And then this heat pump, how do we figure that one out? How, heat pump water heater for space, you're saying that you wanna go to electric?
Yeah, there's really
Okay.
high efficiency heat pump water heaters, and there's, you know, again, what, I mean, I can put mine in myself. We don't typically do, we used to do all kinds of stuff because we're general electrical, plumbing, and solar. But there's so little interest in a lot of this stuff, unfortunately, that we just focus on solar. But there's lots of people in the area here that not only do solar, but all kinds of advanced water heaters and heat
Electric,
pumps. Electric, heat pumps,
So don't
electric.
even worry about on
heat pump water
demand gas,
heaters.
just go for electric,
Well, on-demand gas can be an option,
okay?
but it depends.
Thank you so much, Ray.
Thanks.
Give your round of applause. So if you didn't get a chance to sign in the registration tables there, I would like to get everyone's contact information so that we can disseminate this presentation to all of you for more details. And then, of course, to let you know about any upcoming workshops. There will be one in June that will focus on heating and cooling, including electric heat pumps for water and for air. And that will be taught by a local expert here in Nevada County. So thank you all for attending again. I also want to thank the Grass Valley Courtyard Suites for offering this beautiful conference room for all of our events free of charge. This was an amazing opportunity for the working group to provide a venue for this series. And then I want to thank our videographer, Michael West, for donating his time and creating the video for the. And then I will let all of you know when these workshops are in a video format available online. So thank you again, and I hope that you can come to our next workshop.
Which
Have a
is
good night.
the third?
Thank you.
Yes. There's plenty of food